A very good day, Abid to Dr. MUS'AB. We are from Group 11 and would like to present our findings on Aloha simulation project on butyl acrylic accident release at Basf Petronas Chemicals. But first of all, I would like to introduce our group members, which are NURAINA, HANIS, Muhammad Noor, Aina, NABILA, AHMAD, RUZI, THARANIA, anak perempuan BALAMURUGAN, and me, myself, LYANA, AQILAH. Okay, so basically this will be our brief contents on our presentation for today. So for the introduction, basically BASF is an integrated petrochemical complex located at Gebang, Pahang. And this company produces various chemical products such as olefins, polymers, fertilizers, and many more. And the production capacity involves 12.8 million metric tons per annum. So in this study, a spherical storage tank containing butyl acrylic are assumed to be leaking through a hole at the bottom. This caused unwanted events such as toxic vapor dispersion, fire, and also BLEVE explosion. So, our aim of this study is to identify the consequences of this event and also comparing between the difference of wind speed with the distance, and also we are proposing several recommendations and mitigation steps.
Result discussion scenario 1, wind speed at 2.8 mph. The parameter used are humidity at 80%, hole diameter is 10 cm, stability class is F, partly cloud, temperature at 25 degrees Celsius and tank diameter is 15 meter. The consequence of the event is R, toxic LOC, full fire, BLEVE or explosion. The first consequence of event is toxic LOC. The red zone where the concentration at 250 ppm, toxic dispersion reaches the distance of 205 meters, affect the facilities and nearby area. The orange zone, toxic disperses to the atmosphere greater than 35 ppm. The distance ranges 792 meters from the point source, affected areas starting from the source to Balok Perdana. The yellow zone, where the concentration at 0.05 ppm, toxic disperses ranges greater than 10 km. The toxic release reaches until Barcelona area and enters Terengganu state. As shown in the figure, the red zone where the heat radiation at 10 kW per square meter, it can cause deaths within 60 seconds to people a range of 23 meters from the point source. For the orange zone with the heat radiation at 5 kW per square meter, it can cause second-degree burn to skin within 60 seconds, and the range of area is 34 meters from the peaking tank. The yellow zone with the heat radiation at 2 kW per square meter, it can cause pain to human within 60 seconds, but the affected area reaches 53 meters. Red, orange, and yellow zone would only affect the surrounding facilities. The third consequence of event, which is BLEVE or explosion, the red zone with heat radiation at 10 kW per square meter, it can cause fatal threat within 60 seconds to people ranges 1 km from the point source. It covers from the operational facilities until Kampung Hulu Balu, which is a residential area. The orange zone with the heat radiation at 5 kW per square meter, it can cause second-degree burn to skin within 60 seconds. The distance of roughly 1.5 km from the point source. Affected area is nearby area to the Pusat Perkhidmatan Gebang. The yellow zone where the heat radiation at 2 kW per square meter, it can cause pain to individual within 2.2 km from the leaking area.
So hi, we are moving on to the next part, which is discussion of scenario 2, where the parameters are also the same as before, and the consequences are also same, which are toxic LOC, is pool fire, and also BLEVE explosion. So for the first part, which is toxic LOC, level of concern. So the red zone, which at 250 parts per million, the dispersion reaches 159 meter and destructing nearby facilities and area. For the orange zone, for 25 parts per million, the distance ranges from 8 to 5 meter from point source, and also reaching Sungai Balok. And the last part is the yellow zone, 0.05 ppm per million. The toxic dispersal range greater than 10 kilometers. for the next part is pool fire, where the red zone range from, as you can see from the figure, from 20 meters with heat radiation of 10 kilowatts per square per meter and cause death within 60 seconds. Meanwhile, for the orange zone, the range area of 34 meters with heat radiation of 5 kilowatts per square meter, and it causes 2-second-degree burn to skin within 60 seconds, and the yellow zone affect 53 meters area and heat radiation of 2 kilowatts per square meter, which causes pain to individual within 60 seconds, generally affect the surrounding facilities. And so for the last part for our scenario 2 is the BLEVE explosion. Okay, so in this case, it's not moving. Hang on. Okay, for the next scenario, the EVE explosion, the red zone ranges 1 kilometer from point source with heat radiation of 10 kilowatts per square meter, which can cause fatal threat within 60 seconds and covers hulu balok radiation is 5 kilowatts per square meter, which can cause second-degree burn also within 60 seconds, and it is where pusat perkhidmatan Gebeng are one of the affected area. And the last one is the yellow zone, which can cause pain to individual within 2.2 kilometers from leaking area with heat radiation of 2.0 kilowatt per square meter, and this area covering until Padang Serai. So
now I'm going to explain our scenario 3, which is a wind speed at 11.43 mph. So our incident is toxic LOC. As figure shows, the influence of wind speed, the concentration of the alkali in the range of greater than 180 meter is the height as 250 ppm, which is concentration at rate. So all BFSF worker were exposed to this chemical. Long-term exposure to respiratory illness may result in disease of the airways involving difficult breathing and related to skin problems. So in the range of 1.4 km orange area with concentration 25 ppm, the material may cause a mild but significant inflammation of the skin and the respiratory irritation. For the yellow area, the range is greater than 10 km with 0.05 ppm. There is no health effect other than to cause drowsiness and dizziness. The people who lived around the chemical plant were also exposed to the chemical but not bad as a BASF worker. So this result we get for toxic LOC. So our second idiom is pool fire. So from figure it can be seen that once the Boti alkali tank leaks and cause a pool fire, the equipment and building could be damaged completely within the scope of 30.0 meter by thermal radiation 10 kilowatt per square meter. All people were dead within 1 minute. This range is under the red area. So in the 40 meter range, orange area with the thermal radiation 5.0 kilowatt square meter, the people will be exposed to second-degree burns within 1 minute and deform a steel structure equipment under the normal circumference. So in the 58 meter range, in the light injury area, yellow area with 2.0 kilowatt square meter, thermal radiation in the region that is more than this range is a safe area. This result we get from pool fire. And then the last incident is a BLEV. So the flammable liquid is when explosion catch fire causing a fireball to the generator. The figure shows the result of boiling liquid expanding vapor explosion simulation. So the coefficient of the incident were catastrophic. The equipment and building could be damaged completely within the scope of 1.0 km with thermal radiation 10.0 kilowatt square meter. All people died within 1 minute when this happened under the red area. So in the range of 1.4 km orange area with thermal radiation 5.0 kilowatt square meter, the people will be exposed to second degree burns within 1 minute. So light injury area, yellow area, range is 2.2 kilometer with 2.0 kilowatt square meter. The thermal radiation is shown in the figure. So this is what we get from Aloha for BLEV. So that's all for scenario 3.
Okay, so I'm going to tell about the analysis of the three scenarios, which is we use the wind speed as different wind speed with as a parameter. So the first table is to show the effect of toxic level of concern for each scenario. For the toxic level of concern by vapor cloud, the lower wind speed bring the larger of area at the red zone, which is 25 0 ppm. And the higher wind speed affected the larger area affected by the medium toxic level of ozone, which is orange, which is 25 ppm. So the next table is to show the effect of thermal radiation from pool fire of each scenario. It known as positive response, which is the higher wind speed, the larger area will be affected by the thermal radiation. For X 11.43 miles per hour of wind speed, the trade zone that has been affected is 30 meter larger than the area affected by the wind of 2.8 miles per hour and 6.52 miles per hour, which is 23 meters. So the last table is to show the effect of the BLEVE, which is explosion, with each scenario with the different wind speed. So the factor of wind speed denote affected by the changes of area or boiling liquid expanding vapor explosion, BLEVE, which is we can see from here the same. So this is because the BLEVE may occur drastically. In addition, the factor of wind speed is unlikely to cause as the plate is nearby with the sea. So the simulation show on how the accident is caused by a leakage. That will bring 3 types of accident BLEVE, which is toxic LOC, pool fire, and BLEVE. So as we know that from the BLEVE, explosion will be more harmful and dangerous as the accident release in red trade zone is largest among the other scenarios. So as we know that the explosion might be affected to other things, human and also animals, such as it may be affect also other storage to be exploded too.
Okay, I'm going to explain about recommendations. So in recommendation, I have 3 main aspects. First aspect is engineering control. Second is administrative control, and last one is personal protective equipment, PPE. So coming back to first aspect, engineering control. So proper design and testing of tank can prevent onset of distortion and possible rupture that may cause leakage problem. So as an engineer, they have to check the tank regularly to avoid any leakage problem. So tank should be located at sufficiently long distance from other tank or vessels that have potential source of fire. So the ground around the tank should have a downward slope which is connected to the safe area. So the collected leakage liquid at the safe area, the operators should be disposed in a good proper way. So facilities for generating water mist barriers close to butyl alkali tank can be installed. It can capture any flammable vapor released from the tank and disperse it without the flammable vapor getting ignited. So fourth one is toxic LOC, pool fire, and BLEV due to runaway reaction inside the tank are much less common than due to accidental tank damage from the outside, such as fire or missile impact. So however, they do occur, a purification should be taken. Hence, the tank should have an instrumentation for continuous monitoring of temperature and pressure. So the engineer can install any equipment like a temperature indicator or pressure indicator to monitor the pressure and temperature of the tank continuously. So the last one is install the flame detectors and automatic sprinkler system at conspicuous location, especially around the butyl alkali tank, so to detect any smoke or heat due to the pool fire or exfoliation, so the emergency team can prepare for fire extinguish. Then next, okay, so the second aspect is administrative control. So managers and supervisors are usually the ones who implement the administrative procedure and operational policies that control chemical risks and hazards. So provide adequate supervision and retaining staff who don't follow the safety instruction. Additionally, safety measures in form of checklists covering do's and don'ts of preventive maintenance and manufacturing utility staff for safety related measures should be updated timely, will be available to all concerned department and personnel. And then last aspect is personal protective equipment. So specific parts of body need to be safeguarded when working with butyl alkali storage tank. because the butyl alkyl is a very flammable liquid and high poisonous. So using a safety eyewear will safeguard employees from dust, vapor, heat and chemical splashes and more. It is important to make sure that the size are right when using the safety glass to avoid the safety glass fall into the chemical or moreover. So the third point is the worker who monitor or operate the butyl alkyl storage tank should wear the suitable glove because the butyl alkyl is very poisonous. So it can affect the skin if it splashes on the skin. Okay, the shoe used should be able to withstand a chemical spill or penetration of pointy objects. So appropriate necessity protection should be used when exposure to butyl alkyl vapors or mist may occur during the exfoliation. So last one is safety shower and high wash facility should be provided in close proximity to where chemicals are being handled. That's all for recommendation part. Thank you.
As a conclusion, this project shows how the incident release was caused by a leakage on the butyl acrylate tank that will bring three types of accidents release, that is toxic LOC, pool fire and BLEVE. The simulation results show that the butyl acrylate tank leaks and causes BLEVE. Thermal radiation intensity of fire increases along with the increase of the wind speed. It means that the boiling liquid expanding vapor explosion has the largest threat zone area than other scenarios, which around 1 kilometer. According to damage and injury criteria, the maximum when thermal radiation intensity is 10 kW per meter square. The equipment and buildings could be damaged completely within the scope of 1 kilometer and all people died within 1 minute. Thus, the BLEVE accident consequence is very serious and dangerous. The simulation results are also important reference value for the study of toxic LOC, pool fire, and BLEVE. Development, environmental impact assessment, and safety design in storage tank areas.